Hello, everyone. I'm Dr. Cameron Hummels, an astrophysicist at Caltech, and I'm going to talk about, for the next few minutes, the green comet and why it's so special and putting it sort of in the context of what we know about it and comets in general. So the green comet has been in the news a large amount in the last few weeks as it comes into the inner solar system and gets bright enough to see with the naked eye. This presentation just gives some idea of how comets behave, what their origin is, what science they can allow us to do, and more about the discovery of the comet in general. So I'm referring to the green comet, but more specifically, this is comet C/2022 E3 ZTF, or as I'm just going to call for the rest of this presentation, Comet ZTF, kind of interchangeably. Now, the image of the comet is really spectacular. It is in fact green. I'll talk a little bit more about that in a few minutes. You can see a really nice tail. And I encourage you, if you have the opportunity to look through a telescope at it, you can see some pretty awesome views. But let's just start at the basics of putting this in context. What is our solar system? Everybody has some intuition for what our solar system is. This is a nice little cartoon showing many of the different objects in our solar system. And really, it consists of the planets and, of course, the sun at the center, moons, dwarf planets like Pluto and other friends of Pluto in the outer solar system, asteroids, comets, spacecraft, and dust and debris. And really, the extent of the solar system extends all the way out to almost a light year away from the sun. So what that basically means is the distance that light can travel in a year. And this is the equivalent to 60,000 astronomical units, which are the distance between the sun and the Earth. So if you think about how far away the sun is from the Earth, multiply that by 60,000, and that gives you the edge of the solar system. Now, why is that the edge? It's simply because that's kind of the region where the sun's gravity dominates over other forms of gravity. Once you go beyond around a light year away from the sun, other stars, other passing stars, or the gravitational potential from the galaxy itself kind of overwhelms things. And so you can think of, if I were to take a rock and drop it right on the interior of this circle, this outer edge, it would plummet in towards the center of the solar system and towards the sun. Whereas if I were to drop that same rock beyond the edge of this circle, it would probably not do that. It would either hang out around there or start traveling towards a different star or something else. So that's really why we call it the edge. And it's around this edge where comets appear to originate. So to answer our first question, what is our solar system? It's this region surrounding the sun, extending to around a light year away and containing all of the stuff that's orbiting around our sun. This is another sort of cartoon basically diagramming what our solar system looks like. And of course, people are familiar with our planets, the inner planets, Mercury, Venus, Earth, and Mars, the asteroid belt, the outer planets, Jupiter, Saturn, Uranus, and Neptune, and then these other kind of mysterious objects in the outer solar system called the Kuiper belt and the Oort cloud. And this is more to scale of what our solar system looks like and the relative orbits of the objects in the inner solar system. And if we zoom out from this particular image, we see what the Kuiper belt is meant to be. So the Kuiper belt is kind of like a donut of objects in the outer solar system surrounding the planets in the inner solar system. That yellow circle represents the orbit of Pluto, which is a Kuiper belt. And again, this AU thing at the bottom designation is an astronomical unit, and that's the distance from the Earth to the sun. So like 30 times to 50 times that distance is where you find these objects in the Kuiper belt. And Kuiper belt is just named after a Dutch guy who proposed these things named Kuiper. So you've got a bunch of icy objects in the outer solar system called the Kuiper belt, and then even beyond that, you can extend farther out to what's known as the Oort cloud, and that is this kind of spherical ball of different small objects in the outer parts of the solar system, going out to almost the edge of the solar system, where you find very icy objects that eventually sometimes fall into the inner solar system and become comets. And again, strangely enough, it's another Dutch guy that this is named after, Jan Oort. So, as I said, these things are hanging out in the outer parts of the solar system, and because it's in the outer parts of the solar system, it's a long ways from the sun, and it's very cold there, and so these objects are composed of ices and dust and so on and so forth. And occasionally, one will undergo some sort of perturbation. Maybe a passing star gets too close and it disrupts its orbit, and it causes it to start falling inward into the interior of the solar system. And when it does, it starts to heat up because it's getting closer to the sun, which of course is very hot. And it starts to showcase this characteristic shape of a comet with a tail and that sort of thing. And so really, where are the comets? Well, they originate in the outer parts of the solar system in this Kuiper belt and the Oort cloud. And sometimes they fall inward. And when they do, they heat up and start to outgas material from their surfaces that makes them have the traditional shape that we associate them with. So why do they look like this in the sky? Well, it's funny, the word comet comes from the Greek word kometes, which means long-haired. And it really does look like it has, a star with long hair here. But why is this the case? Why does it have this characteristic tail? We refer to these objects as dirty snowballs. This is a science demo I did a couple of years ago where we get to build a comet using dry ice and water and some other household materials. And dirty snowball really is a strong approximation for what these comets are. Because they form in the outer solar system where it's very cold, they're formed from a variety of different ices: dry ice, water ice, methane ice, ammonia ices, and mixed in with a bunch of dust and dirt and organic materials as well. So this is an actual image of a cometary nucleus, one of these dirty snowballs. This is Comet Churyumov-Gerasimenko, which we actually had a European Space Agency lander called the Rosetta mission that landed and orbited around this for several years, about a decade ago. And this is an image, and it really does look like a dirty snowball. I mean, you can see it has some reflectance, but there's a lot of dirt and substructure on the surface. Now, these things are pretty small. Cometary nuclei like this are somewhere between, they can get as large as like 20 or 30 kilometers across, but for the most part, they're in the range of 1 to 10 kilometers or 1 to 10 miles or something like that. Halley's Comet is about 10 kilometers or 6 miles across. The Comet ZTF, the one that we're talking about today, is about 1 kilometer across or about half a mile across. So it's really quite small. It's like the size of a small town or even like a neighborhood. So really very small. And when it comes into the inner solar system, remember, it's starting to heat up and it's starting to melt and evaporate these ices. The technical term is sublimate for when something goes straight from a solid like an ice into a vapor like a gas. And that's what's happening. And actually that mission, the Rosetta mission, which landed on Comet Churyumov-Gerasimenko, took active video footage from the surface of the comet, which is really just mind-blowing and spectacular. This is from the surface of a comet taken about 10 years ago. And you can see, I mean, aside from the fact that this looks like a Game of Thrones scene on the wall, which is just crazy, you can see all kinds of snow and dust and debris that's being kicked off as this thing is starting to travel into the inner solar system and losing a lot of that material as it evaporates off the surface and gets kicked into orbit around it. So it's really spectacular. So as that ice and such is melting and evaporating from the surface, you form this gaseous cloud that surrounds that cometary nucleus. Remember, the nucleus is only like a kilometer or a mile in size. Well, this coma, it's called, the cloud that surrounds it of all of this gas, can be much, much larger. It can be 1,000 to like 100,000 miles across. So imagine something, that core, the size of the nucleus is only like the size of a neighborhood, and all of a sudden you have a cloud of gas that surrounds it that's like the size of the Earth, or many times the size of the Earth. And in fact, for Comet ZTF, the diameter of that coma was measured to be something on the order of 100,000 miles across. like 10 times the diameter of the Earth, just enormous. And that's what we see when we look up in the sky. We aren't seeing that little nucleus, that little ice nugget in the sky. We're seeing this enormous cloud of gas that's surrounding it, that's caused by that ice nugget starting to evaporate its material into this cloud. And then finally, the really characteristic thing that tells us that it's a comet is the tail that drags out away from the sun. And that can be even larger. That can be hundreds of millions of miles in length, equivalent to the distance between the Earth and the sun. So all of this caused by this little tiny ice nugget that's like a mile across is pretty wild. Tails come in two kind of types, and you may see this. You can certainly see this with Comet ZTF. There's what's known as the dust tail and the ion tail. These are caused by different features within the comet itself. Essentially, as the comet gets into the inner solar system, it's being heated up by light that's coming from the sun, and that light causes the ices to melt, but it also and turn into gases, and it releases dust, which kind of drags out behind the comet. But at the same time, that light hits those gas molecules and it knocks off an electron, and it ionizes. It causes those gases to be ionized, which means they have some sort of magnetic charge or electrical charge, and they respond to magnetic fields. And what's important about that is, usually when we think of the sun, we just think of the sun as shining, but it's also, it has something called the solar wind. There's material coming off the surface of the sun constantly. This is a video taken with the NASA SOHO satellite staring at the sun, which is blocked out in the center, and you can see this material flowing off the surface of the sun. Now, that solar wind is charged particles, and it drags with it a magnetic field. And so when it comes past the comet, it drags those ions, those charged gas particles, directly outward from its position away from the sun. And so you get this very distinctive two component tail. One that's the ions. The ion tail tends to be blue because of carbon monoxide, charged carbon monoxide particles that are present in those ions. That fluoresce at that color of blue, whereas the dust tends to be more like what you'd think with dust reflecting off sunlight, which is this kind of murky white color. And this is just another kind of cartoon demonstrating this effect. As the comet travels along its orbit, you get the ion tail dragging directly away from the sun, and the dust tail kind of being a combination of away from the sun as well as away from the direction that the comet is traveling, because it carries some inertia with it. This is another kind of diagram showing how you get two different tail components from comets as they travel in their orbit. Okay, and this is Comet ZTF. This is footage that was taken from several frames by a very good amateur astronomer, showing the evolution of this dust tail as it travels away from the sun and away from the comet. I'm sorry, the ion tail as it travels away from the comet. Pretty spectacular. So this comet, Comet ZTF, has been dubbed by the media the Green Comet, and appropriately so. You can see it has this very distinctive green color. That green color, a lot of people are asking, is due to two certain types of molecules that are present in the comet that are released when the sunlight hits the ices and starts to release the various different molecules. These are diatomic carbon, which is just two carbon atoms that are bound together very strongly, and cyanide or cyanogen, that is carbon and nitrogen that are bound together. And when they get hit with additional UV rays from the sun, it bumps them up, it bumps their electron up an energy state, which then drops back down, and when it does so, it releases this very characteristic green color that we associate with this comet. But what's odd is there are lots of green comets. This is not a unique green comet. You can see these are just four kind of randomly selected comets from the last 10 years or so. And they all have that characteristic green color because they all contain this diatomic carbon and cyanide that are present in the comet itself. And it shows up in the coma associated with these. So really calling this the green comet is a little bit of a misnomer. It's like pointing to a person across the street in a crowd and being like, oh, look at that guy, that brown-haired guy, as if brown-haired guy would be some sort of unique identifier. It's not. There are many brown-haired men and there are many green comets. So yes, it is a green comet, but is it special and unique because of that? No, it's not. And in fact, going further, the media is really playing this up as being this unique comet. It's not really. There are lots of comets that become visible to the naked eye. About once every 2 or 3 years, there will be a comet that comes into the inner solar system, and we can see it without the aid of a telescope like this. And that's cool, and that's a visual spectacle, and it's great to get us all talking about science and in astronomy. And because I have a love of comets, I'm excited to talk about them. But there's nothing really particularly unique about this comet as it comes in and has its apparition in the last few weeks. So why do comets look this way? They interact with the sun to produce this cloud and a tail that becomes very bright and visible to us here on Earth. Okay, I just want to throw this in there because I think it's super interesting. What about meteor showers? Everybody's familiar with a meteor shower. It's when you see shooting stars across the sky on a particular night or nights of the year. The most popular ones are like the Perseids or the Geminids or the Leonids that happen in the latter part of the year. And they're basically caused by comets. Remember, comets are traveling in their orbit. They're releasing gases and such and dust from their interior, and that fills their orbits behind them, the dust particles. These can be as small as sand grains or pebbles or sometimes larger boulders, but that basically sits in their orbit as they go repeatedly around the sun. Now, if the Earth ever happens to pass through that orbit, it's going to run into all of those sand grains, and those sand grains are going to travel through our atmosphere and burn up in our atmosphere, causing a bunch of shooting stars to occur all within, a night or 2 nights or 3 nights or something like that. So really, meteor showers are caused by comets like Comet ZTF. We aren't traveling through the orbit of Comet ZTF. We are traveling through the orbits of other comets like Halley's Comet, and that's why we get these sorts of meteor showers. But it's all related. It's pretty cool. So meteor showers are just debris from comets entering our Earth's atmosphere. Okay, so how was Comet ZTF discovered? It was discovered just a year ago by Caltech scientists at the Palomar Observatory. This was the largest telescope in the world for about 50 years. It's in Southern California. It's kind of northeast of San Diego, a couple hours drive, hour and a half drive or so. And this is it's a beautiful, beautiful site. And it continues, even though it's no longer the largest telescope in the world, the site continues to host world-class science that's being done. And one such project is called the Zwicky Transient Facility. And what that means is what that's doing, it's known as ZTF. What it's doing is it's scanning across the sky and making images of the night sky every couple of nights. It'll take a picture over here, and then a picture over here, and then a picture over here. And it does that repeatedly until it covers the whole night sky, at least as visible from the northern hemisphere. And it does it again 2 nights later. And the point is that if you take a picture of some part of sky tonight, and then you do it again 2 nights from now, and then 2 nights after that, and you look at consecutive images, and you look for differences between those images, you can see changes in the night sky. You can see when a star explodes as a supernova. It might not show up in the first image, but it might show up brighter in the second or third images because that was the time scale over which it got brighter. It also picks up things like asteroids or comets that are moving relative to the background stars. And that's precisely how Comet ZTF was discovered. Each image of these 5 images was taken 3.5 minutes after the preceding one. And you can see some of the objects here, these are just stars in the corner, they're roughly the same brightness and same position from exposure to exposure, whereas this object is moving over the course of the 5 exposures. And so we know it's in the solar system and moving relative to those background stars. So this was done March 2nd, 2022. And the team that was credited with the discovery formally goes to Frank Maskey and Bryce Boland. Frank Maskey wrote some of the software for being able to figure out how the what objects were moving. I also include here Dmitry Duev, who did a bunch of the machine learning software for being able to identify the the changing orbits and the changing position of these various different objects that aren't just stars in the background. And then Bryce Bolin was actually the person who identified and looked at the frames and was like, oh, this is a real object. These are all Caltech scientists. And initially it was thought that this was just an asteroid, but as they continued to watch this and people from the community continued to watch this, you started to see a tail develop behind it. So this is kind of a time lapse showing from June 2022 until December 2022. As this object got closer and closer to the sun, this is the distance to the sun, 3.5 astronomical units, and then closer and closer until it got about the same distance as the Earth is to the sun. It gets, as you can see, it develops quite a tail and it gets brighter and brighter and brighter. So why does it, this is the official name of the green comet, or Comet ZTF, and why does it have this kind of crazy name? Well, it's basically, lots of comets are discovered, you know, a few thousand comets have been discovered to date, and we have to keep a way of keeping track of all of them in some sort of unique way. So this, basically, all the different parts here mean a different thing. C just means that it's a long period comet, that it has an orbit that takes it longer than 200 years to make an orbit around the sun. In this case, it's about 50,000 years to make an orbit around the sun. This part just means the year and month of discovery. So it was discovered in early March of 2022. The E basically means A is the first half of January, B is the second half of January, C is the first half of February, and so on and so forth. So this is the first half of March. And 3 means it was the third object discovered in that period that was a comet. And finally, ZTF just refers to the team that discovered it. Instead of saying the specific members of the team, it just gives credit to the whole team as a whole. Okay, so how was it discovered? Comet ZTF was discovered by Caltech scientists at using the Palomar telescope as part of the Zwicky transient facility in March of 2022. Where is it going? This is a picture showing its orbit in the solar system, and you can see that, you know, a year ago, it was out around almost to Jupiter's orbit, and it's slowly come in almost perpendicular to the plane of the solar system. And right now, it's basically at its closest approach to the Earth and to the sun. So it's going to be brightest in the sky. But, you know, the media is kind of saying like, oh, you have to see it right now or else it's gone forever. Well, that's not true. I mean, it's not vanishing. It's just traveling into the outer solar system, and it'll get progressively fainter over time. But you can still see it if you look up in the night sky. Because it's moving through the solar system, its position appears to change every night relative to the background stars. This is just giving us an idea of where it was in January and then now into February. Right now, it's in the constellation of Auriga, if you're looking. And finally, this shows its brightness over time. And so a year ago, it was very, very faint. You had to have a very powerful telescope and know exactly where to look, where to see it. Whereas on February 1st, at its closest approach to the Earth, you could see it quite readily from a dark sky sight. It was above the naked eye limit, so you could see it unaided if you knew where to look. You didn't need a telescope or binoculars, although here in Los Angeles and Pasadena, we have a lot of light pollution, so it wasn't necessarily possible. But I was able to use a telescope in front of my sidewalk on my apartment building in a pretty, as you can see, light polluted place, and I was able to take this humble image of the comet. You don't see the green color, but you can definitely see the halo, or rather the coma of the gas cloud that's kind of surrounding it. And yeah, this is kind of representative of what you might be able to see with okay optics, a reasonably decent telescope or binoculars or something from an okay site. So where is Comet ZTF going? It's traveling back to the outer solar system. It's fading in brightness slowly. And honestly, it has this 50,000 year period. We believe that it came into the inner solar system about 50,000 years ago based on its current orbit, and it's made multiple passes in the past. But due to its outward trajectory, it's on the edge of whether or not it's actually going to return into our solar system. It might continue beyond and become unbound, gravitationally unbound. It has an eccentricity of just around 1, which is when something is no longer bound to the solar system. So we don't really know. But either way, we probably won't live to see its next passage if it does have one. So in summary, comets are these dirty snowballs that form in the outer solar system, and they start to develop this comet-like shape that we associate with them when they come into the inner solar system and start getting heated up with interactions with the sun, both from the solar wind as well as from light. Comet ZTF was discovered by Caltech scientists as part of this ZTF survey about a year ago, and it made its closest approach just last week on February 1st before heading back out into the outer solar system or potentially beyond. And then, honestly, Comet ZTF isn't particularly special. There are lots of green comets. There are lots of bright naked eye comets. But it is cool that everyone's excited about comets and science right now. So I figured I'd give some sort of context. Don't despair. There are 2 more comets that will be visible. Well, one just next year, Comet 12. Keep an eye out for Comet 12P Pons-Brooks that will probably be as bright or brighter than Comet ZTF in about a year's time. And hopefully we'll all live long enough to see the next apparition of Halley's Comet that's supposed to come through here in 2061. It has a period of about 75 years. It was last year in around 1986. And has been coming here for centuries. So that's always a great comet to see. So that's about all I've got. Once again, my name is Dr. Cameron Hummels. Thanks for your attention. Hopefully you got something out of this. If you're interested in future events like this, check out our Caltech Astronomy Outreach YouTube channel or website. We have lots of free public science education events with telescopes and everything, both online, live streamed, in person, and then lots of recordings. So thanks for listening, everybody. Have a good one.